Okay, I think it's time to start. Did you guys have coffee? Twice. Good. Did you have a coffee to go? Because you're going to need it, right? When we did that same session in London 2 days ago, the hospital was just across the street. So I was telling people, if you have a machine learning overdose, we can actually rush you to the hospital. I'm afraid here you'll have to suffer through that, right? So bear with me, all right? But you're strong here, so you can take it. Okay, so in the previous talk, I gave you an overview of the high-level services. And we're going to try and close those blinds for you to have a better picture. Oh, there we go. Awesome. Thank you very much. Technology. It's perfect. Good synchronization, too. And in this session, I'm going to actually dive deeper. And here's that stack again. So the high-level services, poly recognition, and so on. But we have a couple more that deal with personalization and forecasting, and I will cover those. But I still consider them to be, slightly more machine learning services. So we'll see. And we'll talk about SageMaker a lot, and especially a lot of the new services that have been added to SageMaker. And we'll talk about the lower level as well, the new instances that we added, and new optimization features too. Okay. So when we launched SageMaker last year, our purpose was to make machine learning simpler. Okay, make it accessible to developers who didn't have a lot of machine learning experience, and generally make machine learning simpler, more agile than it was, to let people experiment and go quickly in production when they were ready. And so this year, that ease of use theme is still present, but we also worked on 2 additional themes, improving cost. That's always important, right? I don't pay my AWS bills, but you do, right? People say that's the reason I joined, but they might be right. And making it easier to work with data, right? Building data sets is a pain, especially when you work with large ones. So trying to make that simpler too. So let's start with cost, right? Money, money talks. So let's focus on this first. See how we can help you save money on training and inference. So the first significant thing we announced is a new P3 instance. Okay, so if you're not familiar with P3s are GPU instances that run the NVIDIA 100 GPU, which is the top one today. And you can get from 1 to 8 in a single server. That's a crazy amount of training firepower. And so please meet P3DN. It's a new bunch of instances. They still run the NVIDIA 100, but they have upgraded RAM and CPU capabilities, right? So basically that's going to help you run bigger training workloads, bigger training scripts. They have more GPU memory, right? So that's going to help you, again, run bigger workloads on the GPU. And importantly, I think, they support 100 gigabit networking. And why is that important? Well, 2 reasons. First, obviously, is the fastest you can download your training data to your training instances, the better, right? If you're training on terabytes of data, images, video, whatever it is, you have to send that data to the training instances. So if the network's faster at doing that, then you save time, and if you save time, you save money, right? Because your training job takes less time. The other thing is, when you train on large data sets, probably you will use distributed training. You will use multiple instances collaborating on the same training. Again, SageMaker supports that with TensorFlow and MXNet and the built-in algos, etc. It's very easy to set up. But of course, during training, right, those instances, they have to exchange data. Okay, for example, if you train a deep learning model called ResNet, so it's a complex convolutional neural network for image classification. Each instance is going to work on their part of the data set, and periodically they have to exchange information to build a model. Okay, the gradients, if you know a little bit about deep learning, the gradient information needs to be exchanged. And this can be, up to 50 megabytes for complex models, maybe even more. So at the end of each training round, each instance has to push 50 megabytes to a central server that adds up everything and distributes it again so that all the training instances actually train on the same model, right? And so that's a lot of overhead, right, if you have slow networking. So that 100 gigabit networking is going to shorten that time as well. Okay, so you download data faster, you exchange training data faster, so you just train faster and you save money. Okay, this is really, really significant. The next improvement that we've done is actually on TensorFlow. So continuing on that theme, if you do distributed training and if you do it at a large scale, you might end up running your training job on a large number of CPUs. Okay, like I said, the largest P3 instance has 8 NVIDIA GPUs. So, you could have maybe 100 GPUs collaborating on the same training job. But the problem is that TensorFlow does not scale linearly. Okay, so at some point, when you have, double the hardware, double the number of GPUs, you don't get double the performance. You don't get a 2x speed up. So it tends to flatten, which is bad because it means that any additional money you threw at the problem is not well spent. And of course, you're not speeding things up. Okay, so the best TensorFlow could do was 65% efficiency. So instead of having perfect linearity, we would have only 65% of that. So not very good. So our own teams worked on TensorFlow and they improved it. They improved the scaling capabilities. And now if you throw 256 GPUs at a deep learning problem, you get 90% efficiency, meaning you scale almost perfectly linearly from 1 GPU to 256 GPUs. So if you were training on let's say 64 GPUs and you had 64 more, your training time will be divided by 2, almost all the way up to 256. So now any money that you spend is actually well spent, and you get the training speed up. Okay, so this is available in the TensorFlow version running in SageMaker and the deep learning AMIs. And what this means from a training time perspective, and this is training ResNet 50, I think again, the fastest lap time for that was 30 minutes, right? From a team in Mountain View, whoever that might be. Okay, 30 minutes. Now with this version, we're down to 14 minutes. Okay, so I'm told this is the fastest training time ever for this specific scenario. So now you can train a full ResNet 50 on probably on ImageNet on a large data set in 14 minutes using 256 GPUs. Okay, so it's not about setting records. Personally, I really don't care about that. It's about making sure whatever money you spend to speed things up actually speeds things up, right? So now that's the case. So that's what we do on TensorFlow. We also added a feature on MXNet for now. So MXNet is another deep learning library. And still on that distributed training theme, when you do distributed training, the number of instances that collaborate is fixed. So you decide on, okay, let's use, I don't know, 8 instances or 12 instances, and they will go from beginning to end and train that model. Okay. Now, what if you had unused capacity on the side, right? Could you throw it at the problem as well? Okay. Well, that's really what dynamic training is. So if you have reserved instances, okay, if your company bought reserved instances, and at the moment, right, they're not doing anything because no one's using that capacity, you could take that reserved instance capacity and throw it at an MXNet training job. And if you need it back 2 hours later, you can take it back. Okay, so it's like I said, dynamic training is a capability that lets you add and remove instances on long-lasting training jobs. Okay, and you have to realize, of course, when we're experimenting, we're training for 3 minutes. So it makes no sense to use that. But when you have large-scale scenarios, you could be training for hours and maybe days. Okay, so if you have unused capacity that you're paying for, because you paid for those reserved instances, and they're doing nothing, well, why not throw them at the problem? Okay, and if somebody needs them for, I don't know, to deploy web apps or something different, then you can take them back. And the cool thing is we can do this without any loss of accuracy. That's that graph on the lower side here. So the blue line is the baseline. So it's training with a fixed number of instances from beginning to end, and we get to about 80% accuracy, okay? And the green line is actually the dynamic scenario, and the orange dots show you the number of GPUs involved in that training. And you can see it changes all the time from maybe 8 all the way up to 128. Right? You can see the right-hand scale, okay? And you can see it trains just as fine, right? No loss of accuracy, so the fact that instances come and go, you don't lose any information, right? MXNet has been modified to account for that, okay? So it's MXNet and reserve instances for now. We're working on adding spot instances, which will let you probably scale even higher at very little cost. And we're also working on additional frameworks. So hopefully, TensorFlow, PyTorch, other things. Okay, so very cool feature that lets you speed up training jobs, in this case at no cost, because you already paid for the reserved instances and you're just putting them to good use, right? So this is what we've done for training. Now, what about predictions? And you can say, well, training is the big cost factor, right? Well, not quite, because training is quite intensive, but then it is kind of limited in time. And then you deploy models, and you live with those models in production for days and weeks and months, potentially deploying them to tens or hundreds of servers, serving live predictions to business apps, mobile apps, and whatnot. Okay, so the actual major cost is prediction. Okay, and the complexity is prediction, because you might need to deploy the same model in different apps with different requirements. Okay, and that's one of the main problems. One size does not fit all. If you're deploying a model inside a large web app, okay, let's say it's embedded in your app, in your web app code, well, of course you're going to worry about prediction performance, but what about application performance? It would be stupid to have excellent prediction performance, right, on that local GPU, and crappy app performance, right? Right? If the latency for the web app sucks, then okay, it doesn't matter if your prediction is fast. So you really need to worry about two things. You need to worry about application performance. What kind of instance do I need for that web app to run well? How much RAM do I need? How many CPUs do I need? Blah, 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 blah. How many I/O do I need? And yeah, okay, how much GPU acceleration do I need? But you have to balance that. And from one app to the next, maybe you need a very CPU intensive instance for a web app, and maybe you need a more RAM intensive instance from an internal business app. It's never going to be exactly the same. So you need to adapt, and you need elasticity as well, right? So the first thing that we've done to make predictions a little faster generally is the new C5 instance family, so called C5N. And so those go up to 100 gigabits as well. Okay, so if you need super high throughput predictions, and generally predictions do not require GPU instances, you can run very well on CPU instances. And if you need a lot of throughput, low latency predictions, then the larger C5Ns are probably worth trying. And if you're really looking for the shortest prediction time possible, you can actually tweak the instance settings using those weird Intel features like C states and P states and turbo boost and all those arcane settings. And you can go up to 3.5 gigahertz single core speed. So you could be running your prediction on a single core at this speed. Okay, so this plus 100 gigabit would give you very, very low latency predictions if that's what you need. Okay, so you can tweak that. So that's pretty good. But I guess the bigger thing, in my opinion, one of the bigger announcements is what we call elastic inference. So elastic inference is simply put, is a way to attach acceleration to any EC2 instance. Okay, so now you can pick the instance size that really fits your app. whatever that app is. So figure out the app requirements, RAM, CPU, I/O, etc. Okay, and make sure it runs fine. And then you can attach an accelerator, and you have 3 sizes to that instance. Okay, and I'll use this feature in the SageMaker session. Okay, and the only thing that it takes is an extra parameter when you call the run instance API. Okay, just one single extra parameter saying, okay, use a medium, large, or extra large accelerator, and that's it. Okay, and then you can use that in TensorFlow. You can use that in MXNet. It hardly requires any code change. Right? Just use that accelerated context instead of the GPU context. It's a very, very tiny modification, and you can benefit from that. Okay, and I'd say the coolest thing about this is when you add up the price of the EC2 instance that you used, let's say you use a C5 instance, and the cost of the accelerator, right? You end up saving about 75% compared to the cheapest GPU instance, which is the P2XL, I think, right? So it's a huge discount. So you literally get the best of both worlds and a discount, right? You get the best instance type for your app. You get the level of acceleration that you need, so you're not over-provisioning by using a full-fledged GPU instance, and you're saving money. Okay, so this is a killer feature. If you're using GPU instances for prediction today, please try this instead. Take a smaller EC2 instance. Start with the small size, or the medium size actually, which is the smallest one, the medium accelerator, and benchmark again. And you may very well find out that you have very good performance at 70% discount. Okay, so this is a huge cost reduction opportunity if you're using GPUs today. All right. Okay, so plenty of ways to save money, right? I think that's good news. Yeah. Save money, right? Save money so that you have money to experiment on something else. You can give a little back to the CFO. That's what I did. Oh, I'm on film, so I shouldn't say that. It's too late now. Okay, so give 20% back. Say, hey, boss, we saved money, and they're happy with that. And keep the rest and experiment with the rest. Okay, but I didn't tell you. So let's move on to the second theme. The second theme is how do you make the data sets simpler to build? Okay, and let's take an example. Anyone here working with, let's say, autonomous drivings or video data sets or complex things? Okay, not yet. That'll come. All right. So let's say you want to label hours and hours of video for autonomous driving. Okay, so you're not labeling the video itself. You're actually labeling frames. Yeah. So you're going to extract those frames. And it looks like this is 3 times the same thing, but it's actually, no, it's 3 different frames. And you would need to do something like this. It's called semantic segmentation. Okay, so it's a complex word. If you have kids, right, if you have 5-year-olds, you have this thing on the fridge, pretty much. Okay, now deep learning people call it semantic segmentation, right? So I prefer the 5-year-old version. So what it is really is each color actually defines a different thing. So that greenish, yellowish thing is, trees, I suppose. The pink, or is that cyan, or pink? The pink stuff is the pavement, I think you guys call it. Yeah. And the bluish, whatever that color is, are vehicles or vans actually, and the car is some kind of purple. Okay, so basically semantic segmentation means assigning each pixel in the picture to a specific object. Okay, and you use a different color for that. Okay, and then you can train a deep learning model on that, of course, so that hopefully in real time you can tell the difference between the white van and the old lady trying to cross the street, right? And hopefully apply the brakes when you need to. So this is what you have to do, okay? So how much time do you think it would take you to do one frame? Carefully, right? With the right level of quality. Any idea? I don't have a number. I'm just asking for pointers. 10 minutes? Yeah, if you have OK tools to do it, right? Like I guess 10 minutes, 10 minutes. Okay. Okay, so imagine you have to do this. Okay, 30 frames per second. Okay, so let's say 5 minutes. That's 150 minutes per second, and you need to do it for a few thousand hours. All right. Now you're updating your resume and looking for a different job, right? Okay. Hopefully. So it is a lot of work. You need the tools, you need the manpower, and no single company has the manpower or wants to pay them to do this. Okay. So to make that simpler, we launched a new service called Amazon SageMaker Ground Truth. So it's actually a feature in SageMaker. And if you're not familiar with the term ground truth is a machine learning term that defines what a sample is. When we do supervised learning, we provide the data set and we provide labels. Okay, this picture is a dog, this picture is a cat, this tweet is a positive tweet, this tweet is a negative tweet. Okay, this information, that label, it's called ground truth. Okay, and so we're trying to make it easier to build those complex data sets. Okay, so let's see how that works. So you start from raw data. So you would have your video frames extracted in S3, for example. And you have some humans annotating them. Okay, and we'll see what the options are for those humans. Then you can train. You can use a technique called active learning. So we automatically, SageMaker trains a machine learning model and tries to annotate additional samples automatically. Okay, saving you time and money. Okay, and you can still have, a fraction being annotated by humans, and you can feed that back into the model. Okay, so by iteratively training a model, looking at what humans do, and improving on what the model learned, you can actually probably automate 70-80% of the work through active learning. So you don't need such a huge human workforce to do it. Okay, and all of this happens automatically. You don't need to mess with training models. You just dump your data in S3, find some humans to work on this, and off you go. Okay, so what about those nice humans, right? It's good to see we still need humans. So we have three options. You can use a long-lasting Amazon service called Mechanical Turk. Mechanical Turk is a service that lets you push tasks. It could be any kind of task. In the past, people have used that for to clean data or label data, etc. And you have up to 500,000, actually more than 500,000 people working on this worldwide. Okay, so if you want to make money on the side, you can actually work as a Mechanical Turk worker, labeling images or labeling tweets, right? Okay, why not? So you can leverage that, and that means you can actually scale your data set building activities very high, right? Without using internal resources that work on something else. If you have to use internal resources, let's say you're labeling medical images, and these are really complex, then probably you need medical professionals to do that work, right? You need specific skills to do that. So you could build a private workforce using people in the company or contractors, but anyway, people that you know and people that you know have the right skills. Or you could use third-party vendors. You have a number of companies out there that provide a specialized workforce that can actually figure out complex problems. Okay, so you have that option. So of course we want to do a demo, right? So let's try and do that. Okay, so let's switch to SageMaker. So I have a very small data set because in the interest of time. So what I did, I took 3 images, right? You may have seen those guys before. Maybe they played that stadium, I don't know. And I want to, so basically those are in S3, and I built a simple a manifest file. Actually, the manifest file is just the list of images in the dataset. Ground Truth can also build it automatically. And here I'd like to build a model that detects guitar players. Okay? So that's my dataset. So first I'm going to create a workforce. Okay, so I could go public, private, or vendor. So keeping it simple, I have a private workforce. It's called Builders Day. And it's not a really powerful workforce because it's just me, right? Right? It's just me. So that's my private email address. If you ever use it, I'll use AWS to DDoS you, okay? So you have been warned. So I'll hide it. Okay, so it's just me. You can invite workers and you get an email saying, hey, welcome to that workforce. Please click on this and change the password and blah, blah, blah. What this really does is it creates a Cognito pool. So Cognito is one of our security authentication services that lets you authenticate users for web apps, mobile apps, etc. And it's all created automatically. And then I get a URL. Okay, so that's actually in the email that I get, where I can log in, which I did. Okay, so now, happy worker. Here's your task, right? So should I start working? Okay, so I'm going to start working. Oops. So you can provide instructions. So I provided some simple instructions. Draw a box around guitar players. Ignore all other people, including bass players. Let's not get into that debate, right? And you can also provide some visual cues, some examples. Okay, this is a right example. This is a wrong example. It's a simple HTML page that you can build in the console to send some instructions. Okay, so fine. I'm going to close this thing and I'm going to get to work. All right, I'm going to go and try to do this right. And then it creates all kinds of interesting questions, because should I do this? Or should I do this? That should probably be part of the instructions, right? So let's grab the guitar in there. Okay. Submit. Adrian Smith, labeled. You know those guys, right? Yeah, I'm showing my age now, I know. Okay, there we go. And I really should have used Irish bands. Sorry about that. Next time. Okay. Now this one is more difficult now. Okay. So, okay, let's try and, grab the minimal area here. And let's get that other guy. Now, okay. See, if I do this, probably it's not, it's not right. There's another person in the frame, so I'm actually gonna stick to this, right? 'Cause probably the guitar is what matters most, and the hair, of course. That's how you tell guitar players from everyone else. They have nice hair, right? I'm jealous. Okay, submit. Okay, and I'm a happy worker. I'm done. I could go and have a beer. So this is how it works. Okay, you can do. So gotta wait. It's gonna run for a bit, and then I'm gonna see some extra information. You can actually create. So creating a job is very simple. You define where your data is. Yeah, and that's what I want to tell you, and what the task type is. So you can do image classification, so just text labels applied to an image. You can do bounding boxes, like I showed you. You can do semantic segmentation, so actually drawing the outlines of everything. And you can do text classification. And it doesn't have to be positive or negative. It could be multiple categories, like this is sports, this is music, this is politics, etc. Or you could do custom jobs. Okay, and I have to say, I haven't had time to dive deep into that, so not sure how custom you could go. But okay, you can look into it, and so should I. All right. So now so it still says in progress. It's going to say in progress for a few minutes. I can show you what it looks like on that previous job that I run. So in the console, you see the actual labels that or the bounding boxes that have been applied. If I click on any given picture, I'm gonna see, confidence score. Here I was just, the single person annotating this. Typically, you would probably have 2 or 3 people annotate the same data and then average everything. And SageMaker can do that. And of course, if this was using active learning, which I did not configure because I only had 3 samples, then you would have a confidence score for that as well. Okay, and I guess what I really want from this is the output. So let's look at this. And in S3, I get an updated manifest. Oh, access denied. Interesting. Okay. Oh, yeah, because I deleted it, I think. All right. Doesn't matter. I can find the other ones. Let's see if we have the manifest already. And this manifest now has all the annotation information. Yeah, it's still crunching it. Okay. Well, we'll come back to that later on. Okay. But in the output manifest, you see the actual bounding boxes and everything. And then the next step, of course, would be to take that information and feed it into an object detection model. Okay. And as it turns out, there is a SageMaker. There is a SageMaker notebook. Let me show it to you. That shows you how to use those that manifest directly and train an object detection model. Okay, so just find that notebook on GitHub. Okay, this is the repo name. And it shows you how to use that information with the original images to train a model. Okay, so it's super easy. And that's one of the built-in algos, so no machine learning code required. Okay, so now it's actually very easy to go from raw data to annotated data to model. Okay, much easier than it was before. All right, do we have the manifest now? Takes a few minutes to show up. Here we go. No, it's going to make my life miserable. Okay, fine. Can I download it, maybe? Ah, here we go. All right, so it's JSON, so it's not for humans, but you can see for each image, I get annotation information in the bounding box and the actual category that was applied. Okay, and this is what you feed into your object detection model. Exactly that information. All right. Let's keep going. Okay, so labeling complex data sets is now easier and scalable. Right, very scalable. You can really tap into a Mechanical Turk and get thousands and thousands of people to work on your data. Okay, so that's an option you probably didn't have before. So what about making everything simpler? So as I've said before, SageMaker was released trying to make everything simpler when it came to machine learning. When it comes to machine learning, so going from experimentation to training to deployment. Yeah, you have a question? Sure. Absolutely. So the question is, if you have your own model, can you train it? Can you deploy it on SageMaker? And the answer is yes, because each of those things is a separate API, pretty much. Okay, so like I say all the time, enter anywhere, exit anywhere. Okay, you're not stuck. It's not like a silo where you have to go our way or the highway, right? You just, if you want to train in SageMaker and deploy on your laptop, you can do that. If you trained on your laptop and want to deploy on SageMaker, just import the model to S3 and deploy. You know, it's a set of APIs, and you can just use whatever you want in there. So pick what you want, leave the rest. Okay, and you'll see that in the SageMaker session. So let's focus on the built-in algos. So I'll talk about those deeper in the SageMaker session. But when it comes to complex problems like recommendation and managing time series, you could use built-in algos like factorization machines and deep AR, which is actually an Amazon invented algo. And you could apply those built-in algos and solve those problems. But I spent some time doing that, and it's fair to say you still need quite a bit of expertise to prepare data. It's mostly on the data side, right? The secret sauce in recommendation time series is usually data prep. It's not so much the algo, it's really how you prepare the data to get good results and what parameters you use for the algo, etc., etc. So, okay, if you're really good at this, which I'm not, you could get good results. So, how about we try to make it simple? So, this is why we introduced two services. So the first one is called Amazon Personalize, and this is a fully managed personalization and recommendation service. Okay, so now you can just bring your data and run a couple of simple APIs that require no machine learning skills and get to an efficient recommendation model. Okay, so in the interest of time, I'm not going to do the full demo. I'm just going to walk through the steps, and you can go and try it out. And this is in preview right now, by the way, so you can join that preview. Okay, so I'll just steal from my own blog post. So here, we're trying to build a movie recommendation solution, okay? So we use a data set called MovieLens, which is a well-known data set with items, so movies, users, and user item interactions, okay? And that interaction file looks like this. So user ID, movie ID, rating, and timestamp. We're ignoring the timestamp. So what this means is user 1 assigned a 3.5 rating to movie 2. He also assigned a 3.5 rating to movie 29 and 32 and 47. So it looks like user 1 likes that 3.5 rating, right? But actually ratings go from 1 to 5. And we have about 20 million ratings. And you can say, wow, that's a lot. Well, that's not really a lot. Because if you multiply 27,000 movies by 138,000 users, let's do that. Because I can't count. Okay, so 27,000 times 38,000. Okay, so, right, and we have 20 million. Okay, so this means we have 0.5% of all possible recommendations, right? So if you built that matrix with items and movies, movies and users, and put a 0 when you don't have a recommendation, right? Actually, 99.5% of all cells would have a 0. So it's called a sparse data set. It's a very sparse data set, and that sparsity it is what makes those problems difficult, because you don't want to manage that crazy amount, that like 300 million or whatever that is, even more than that. It was, yeah, more than that. You don't want to manage that huge data set. So preparing that data properly, focusing on the 0.5% that you actually have and ignoring the 99.5% that you don't have is one of the keys in getting good results. And this is what Personalize will do under the hood. So anyway, the first thing we have to do, I told you would need that coffee, right? You haven't seen the words yet. So we need to define a schema, right? This is the only mandatory file. It's called the interaction file. If you had extra information on users like demographics, you could throw that in. If you had extra information on the movies like genres or, I don't know, year, release years, whatever, you could throw that in. But the only mandatory thing is this, the interactions. So we'll stick to that, define a simple schema, and this really means mapping those columns into keywords that Personalize can understand. Okay, so first column is item ID, second column is user ID, etc., etc. Okay? And the timestamp. Okay. Now to keep it simple, actually, we're going to build a simple recommender that only predicts if a user should like a movie or not. Okay, we're not predicting the rating. It's like you like these, you probably will like these. Okay, so we ignore the rating, which is why it's not here. It's like, okay, we just flag those movies as, okay, that user liked them. Okay, so drop that column. We stick to 100,000 reviews because we don't want this thing to train for too long. Okay, it's just a simple demo. And then, okay, the data set's ready, right? And we can just run a simple command to create a dataset group. Okay, dataset group is what it is. It's just a group of files that will go into the training the model. Create the schema, right, that I just defined. And within that dataset group, create a dataset for that schema and import the file that I copied to S3, okay, with the 100,000 ratings. Okay, so basically define a schema, define a dataset group, and create a dataset from that file using this. Okay, that's not machine learning, right? So where's the machine learning? Okay, and of course it's going to import it to Personalize. It takes a few minutes, and you can wait for that. Okay, so now we have our dataset, and we'd like Personalize to do its magic. So let's say we really know this stuff. Let's say we really know about personalization, and we want to tweak. So Personalize has a number of recipes that you can start from, or you can build your own recipes. So what's a recipe? A recipe is the combination of an algorithm, data preparation, hyperparameters, and probably hyperparameter tuning as well. So it's more than the algorithm. It's the algorithm and how to prepare data for it and how to optimize the model with that algo. So it's a bunch of things. Okay. So we have a bunch of recipes in there. Like I said, you can read about those in the documentation. You could create your own. But man, look at those names, right? Who's excited by HRNN model for metadata? Yeah? That's what I thought. Okay, neither am I. So that would be machine learning, right? So let's not do that. Let's say, okay, well, you know what? Why don't you figure it out for me? I'm not sure which recipe to use. And I definitely don't want to read too much documentation. It's too complicated for me. I don't have time. You should know best, right? Amazon has been building recommenders for 20 years. You should know what to use for that kind of data. So I'm actually going to do that. I'm going to add that simple flag, perform AutoML, that will actually test a number of different recipes automatically and use the optimal one and build my model from that. Okay, so you literally let Personalize select the recipe that is going to be used for your training model. Okay, that's not machine learning. All right. So it's going to run for a while. It's going to do data prep. It's going to do tuning, blah, blah, blah. You get some metrics, so you can look at the results, look at the accuracy, et cetera, decide if that's fine. And if you're happy with those results, then you can create a campaign. You can actually deploy that model. Okay? Do you need to mess with servers? No. Just create that campaign. You can decide to automatically update the campaign, so it will redeploy automatically if you have trained a new solution. So if you have retrained on new data, it updates that endpoint automatically. So you don't need to worry about that either. And then you can get recommendations. So you can say, all right, for user ID 123 or whatever that is, recommend me some movies, and you get movie IDs, right? And of course, you would know that movie 1210 is Star Wars Episode 5 or, whoops. and you could use that in a cache somewhere and display that information in your web app or in your mobile app. Okay. So did we do any machine learning at all here? Nope. We could have if we had wanted to dive deeper into those recipes and so on. But if you're a normal developer, and I mean that in a positive way, you can do this. The only thing that you need to grab is that data set, right? Prepare those columns. That's probably not a very complex SQL statement or some Spark processing, whatever you use to build this. Write the schema, and off you go, right? And within 1 hour or so, you can have a model that you can try. Okay, this is vastly simpler than working with factorization machines and trying to do everything yourself. So it's in preview, but please join and send us feedback. So we introduced a similar service for time series and forecasting. It's called Forecast. So it's very similar. I'm not going to, in the interest of time, I'm not going to go through it, but it's the exact same idea, right? Basic data prep, put your data in S3, and then train a model, and you can use existing recipes, etc., etc. It's very, very similar. The difference between Personalize and Forecast is Forecast also introduces domains. So it has like high-level business use cases that you can select. So it can do supply chain forecasting or sales forecasting, etc. It has 7 or 8 domains that actually point to specific data processing and specific work that the algo does. Okay, so you select that domain, select the recipe, and again, train that solution. Okay, and again, this is much simpler than the previous options. Okay, so this is in preview as well, but again, please join and let us know what you think. So actually, I guess the better way to do machine learning is not to do machine learning at all, right? And so we introduced a marketplace for machine learning models. You're probably familiar with the EC2 marketplace for third-party software. Well, it's the same story. So we have a collection of off-the-shelf models that you can just grab and deploy in a couple of clicks on a SageMaker endpoint. That's as easy as this. So if you're looking for models, that's the place to go. And maybe you should go to that marketplace first and see, hey, maybe there's something nice in there. Maybe I can find the natural language processing model that I like, or maybe I want to find that speech recognition model, and maybe it works well enough for me. So I don't even have to go and train anything. I don't even have to go and build a data set. Okay, click, deploy, try it out on your own data, see how it works. Okay, so we have a bunch of options. And we'll keep adding more. Yes. Oh, here you don't need to train anything. You just deploy them. They're existing models. They are pre-trained models. So you just click and deploy. You can train your own model with your data, if that's your thing. Yeah. So no, in SageMaker you have the list of built-in algos, and you pick from one of those, or you write or you bring your own deep learning code. Okay. Now with Personalize and Forecast, we have the auto ML capability that picks the right algo, the right recipe. Oh yeah, Forecast and Personalize will tell you what they used, right? But SageMaker, you do that work. Okay, you experiment and you figure out which algo to use. Okay, but again, these are pre-trained. Okay, these are pre-trained. So probably they were trained on SageMaker, hopefully, but they're ready to go. So you just deploy them and predict. Okay. So, well, what's the next thing we could look at? The next thing we could look at is, should we optimize models for the underlying hardware architecture, right? Because when we train, we deploy to, I guess the vast majority of models is deployed either to CPU instances or GPU instances. But still, you could think, hey, maybe I want to optimize for that C5 instance. Maybe I want to optimize for that P3 instance. And if you're deploying for on embedded devices, you definitely want to optimize, because those devices have less RAM, less computing power, and they probably need to be super low latency, etc., etc. So today, yes, you could probably grab an MXNet model or a TensorFlow model and do hardware optimization on this, okay? But it's a manual process. So if you want to optimize one given TensorFlow model for one given hardware platform, okay, do the work once, and then you train the next model, and you have to do it all over again. And if you want to deploy on a new platform, then okay, start from scratch. So it's crazy, right? And most people don't do it. So it probably would be nicer if we could do this. Okay, if we could actually automatically optimize models for any platform and just do that automatically, run it again if we need to, but okay, it should be a simple thing, a simple process. So it's actually a new service that we launched. It's called SageMaker Neo, and I will demo it in the SageMaker session. But the basic idea is you train your model just like you would, okay, and maybe it's a model that you already trained and you import it to SageMaker. That's going to work. It's going to work for TensorFlow, MXNet, and ONNX models. So take that model, write a very simple config file. I'll do a demo on the Raspberry Pi if that thing still works, because I keep throwing it around in my bag, and it worked in London, so I'm hopeful. So you take a model, run one API. Okay, so it's one command saying, okay, please compile this model for the Raspberry Pi. Okay, it runs for literally 10 seconds. And then you grab an optimized version of the model from S3. You put it on your device, so the Raspberry Pi, and you use the Neo runtime to load that compiled model, and you predict with it. And I don't want to spoil the speed up that I get, but with this model and this Raspberry Pi, I get 6 times faster on image prediction. Okay, so I'll show it to you later on. And typically you could get 2x on anything else. So 2x even on C5 is really significant, right? If you can magically make all your predictions twice faster by running that command, that simple command that takes 10 seconds, of course you're going to do it, right? It's like free performance, completely free performance. Okay. So we're adding, we have those platforms for launch. We have more hardware platforms coming up, and we will open source Neo so that other hardware vendors can write the code to optimize for their own hardware. Okay. So demo in the next session. All right. So we covered those 3 efforts, right? Saving money. So saving money means faster instances, P3DNs. C5N, faster TensorFlow or more scalable TensorFlow, dynamic training for MXNet using reserved instances. We saw how to build complex data sets using a scalable workforce and active learning to automate things somehow using ground truth. And we saw how you can make machine learning simpler for complex things like forecasting, personalization, using those 2 new services. We saw how to use Neo to compile and optimize hardware, etc., etc., etc. Okay. So is there anything else? All right. Are we done? So no, we're not. Okay. And I will just brush on that topic, which will be covered in detail in the last session today. There's a whole field of machine learning called reinforcement learning, which is a good fit for complex use cases like energy management or robotics or autonomous vehicles. And it's a new way to learn. It's a new way to learn and build complex models, getting really, really close to human behavior. So we introduced reinforcement learning capabilities in SageMaker. Using a bunch of frameworks, a bunch of simulators. I'm not going to go into the details now. If you're interested, last session of the day, running some demos. Bring plenty of coffee, right? It is intense, I have to say. It is an intense one. And you may have seen this car. It's not a toy. It's an autonomous vehicle. It's a small one, but it is an autonomous vehicle. So last year we launched DeepLens to help developers learn about computer vision and deep learning. And this year we're launching DeepRacer, which is an autonomous vehicle that you can actually program. So it's you can pre-order DeepRacer now. You can start working with it. We launched another service called RoboMaker, which is a 3D simulator robots, and you can actually simulate DeepRacer in there. So even if you don't have a car, you can start working with it. And we will, at AWS Summits in 2019, we will have competitions, right? So you can come with your reinforcement learning code, your model, deploy it on a car, and race on an actual track. Okay, that's what we did. We had a race at reInvent already, and we're trying to bring this to all the AWS Summits. So in case you were wondering, this is actually the back of the car, and the camera is on the other side. So the first reaction is, why is it going backwards? No, it's not. Okay, that's the front actually here, right? It's about the size of a shoebox. Okay, so I'll show you a video later on as well. So this is coming, and it's a fun way to experiment with reinforcement learning. So how do you get started with all this, right? This is a bit overwhelming, I know. It's a lot of new machine learning features. So of course, ml.aws is the high-level URL, but another important announcement at reInvent was our own machine learning university. So we're actually sharing with all of you a number of machine learning classes. I think it's 30 or 40 hours, so it's quite significant. And it's based on the same material that Amazon uses internally to train their engineers. So it goes from theory to basic machine learning, all the way to complex business problems like forecasting and so on. So it's free. All you have to do is go there and enroll and learn, right? And get really good at this, right? Okay, so that's the end of this session. I'll stay around if you have questions, or you can run and have lunch and get some calories and caffeine and everything else. Because this afternoon we'll dive deep on SageMaker. I'll show you some of those features at work on SageMaker, Neo, Elastic Inference, and so on. Run lots of demos. Then I'll take a break, and my colleague will talk about fraud detection, and then I'll come back to finish all survivors with reinforcement learning, right? So does that sound like a plan? All right, enjoy your lunch.